All right, so see now the lecture.
هي دكتور.
Perfect. All right. So good afternoon, everyone. Today, inshallah, we'll start with a new topic. It's going to be lecture 6, and we'll talk about another data type. We mentioned previously, it's called strings. And you remember string is marked by a double quotation and should be enclosed with another double quotation, or single quotation and should be enclosed with single quotation. Okay, though I'm writing them in this form, but it's in like this in programming. And if you start with a double quotation, you should end with a double quotation. You started with a single quotation, you end with a single quotation. And we've seen the escape sequences. If you remember, \n, \t, those escape sequences that we put them inside a string, that when you print that statement, it will do something. For example, \n means a new line. \t will do a single tab. All right, now what more we can do with strings? So there are some processes we call slicing. You can change the string. String basically is a series of characters, could be numbers or letters. Sometimes you can change the letters from lowercase to uppercase or the opposite, and so on. All right, so by the end of this lecture, we will, let's say, learn how to access individual characters inside a string. So for example, the word hello. Can we extract like these 3 letters only, ELL, for example, or the letter O, or the letter H? I remember previously in the for loops, when we did the traversing over string, we counted the number of letters, and let's say like that we counted how many E's in a certain string and so on. Basically, we accessed that string, each letter, and we did a comparison with that letter. So here we will learn how to do that by a process called indexing. We will retrieve a substring from a string, like a small string from the string. So this one here, ELL is a substring from the full string, which is hello. And we'll do the opposite. Here we retrieve, here we will look. So you search for a substring inside a string. And we will learn how to manipulate strings using string methods. All right. So here we will examine the internal structure of the string. If you remember in Spider, when you write the word hello, what will be the length here? It's basically going to be the number of characters is going to be 5. So the internal structure here means that I don't have a single element. We have multiple of elements inside the string. Different than x equal 5. The length here is what? It's 1. It's just a single number, single digit. 55. It's also one number. Though it's 2 digits, but that's a single entity, one number. However, if it was like this, 55, that's a string with a length of 2. So that's why there is a huge difference between these 2 numbers, though to us, they represent the same value. Okay, so we will learn also how to extract portions of that string, and we'll call them substrings. All right. An integer number or a float or a number in general, doesn't have to be an integer value, cannot be factored or decomposed into more primitive things. So that's it. X equal 5. That's the lowest portion that you can get. You cannot decompose it into several things. Strings are a bit different, and that's why we call them data structures. Data structures could be decomposed. For example, I'll go again to the word hello. I can decompose it to different letters, and I can do many operations to each letter. Okay, so it consists of smaller pieces of data. That's the data structure. I can decompose it into substrings. And the length of the string, here it's 5. But when you do counting, when you start counting, you start from 0. So the index here, this is location 0. This is location 1 for the letter E. Index is basically the location, 3 and 4. So this one has 5 characters. The character as at index equal 2 is what? Is the letter L, or the character L. So the string length, the number of characters contains, it should be larger than 0. 0 plus. Starting from the empty string that has nothing, and so on. And basically, it's a length. So should be an integer value, and the value should be positive. There is a simple command to find the length of the string. It's just len. Len stands for length. So for example, length of hi there, when you count it, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And in this case, the result will be 9. Now, someone might ask, previously I started with 0 here. Now, when I did the counting, I counted from 1, and that's counting. For example, if you look at my hand, how many fingers are there? 5. 1, 2, 3, 4, 5. But what is the index for my first finger? That's index 0. Index 1, 2, 3, 4. So in indices, the largest index is the length minus 1. What is my largest index here? It's 4. What is the length of my string or the number of my fingers? It is 5. So always the maximum index you get is the length minus 1. So here, hi there, that's a string with the length equal 9, and index 0 is h, that's 0, that's index 1, all the way. What will be the index here? 8, because I started from 0. The length of the empty string is going to be 0. And that's why you see here the decomposition of the string hi there. So the first string, which is index 0, it's h, index 1 is I, and so on. Okay, now to form a substring, we call this process slicing. So for example here, let's assume that the string you have is Alan Turing. And you said name, and you have the square brackets. When you have the square brackets, you are looking for the contents of that index. So here, the string name, that's the string. Alan Turing, if I want to write it, so that's index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's a string of length 11 that has 11 characters starting from 0 to 10. Now, this string is stored in the variable called name. Name equals this string. So when you say name of 0, you are looking at the contents of the variable name. This is the variable name. What are the contents? Alan Turing. And retrieve only the first character or the character at index 0. And that will be the letter A. Like in here. Similarly, name 3. And that's going to be the letter N. Now, here's an issue. Name of len name. Remember, the length will retrieve what? The length of name. Now, what is the length of name? 11. And then you say name of 11. You go back to your string. Is there an index 11? No. So it will return an error. That's the error message. And the last sentence will guide you or give you information about the error. String index is out of range. What is my range? From 0 to 10. And could be expanded. We'll go to the negative indices. But for now, you cannot exceed an index larger than 10. So when you had name 11, that's an error. To fix it, to look for the last element, it's length of name minus 1. You subtract 1. So in that case, it's going to be name of 10, and that's going to be the letter Y, or the letter G. That's the letter G. All right. So this one is to access the last string, to the last, let's say, character in that string. To have a shortcut way, instead of writing the whole thing of the length of the string minus 1, just put minus 1. So when you have an index like this, name of minus 1, that's equivalent to name of length of name minus 1. Those two lines are equivalent. So we can have negative indices as a shortcut way of looking for like the last character or the character before the last, and so on. So when you have name of minus 1, that's equivalent to name of length of name minus 1. And that case, basically, when you have -1, you are looking for last character. So when you have the string like this and you have -1, that's going to be your number. We have -2, so it's the second to the last. It's going to be the letter N. You have it like this. So let's confirm it with simple code, how to do these operations. Okay. So name equal Alan Turing. And we will say, okay, I'll have it like this, line by line, Control C, Control V. So I'll go to the My Variable Explorer, and you see that the name is a string and it has 11 elements. The size is 11, which basically is the length. And you can confirm it by saying length of name, and it is 11. Okay, name of 0 is the letter A. What if I did this? Alan Turing, like the string itself, and I put 0. It is the letter A, because basically the name is the variable name, and what is the content is Alan Turing. So either if you put the variable name or the string itself, they will both lead to the same answer. Okay, so we'll go back to the standard way. Name of 5 is going to be the letter T, I guess. Yeah, the letter T. Now name of -1, so you will have the letter G, which is basically the last character in the string, or name of length of name -1, it will lead to the same thing. So that means that this -1 is equivalent to this command. But for short, do -1 instead of writing this whole thing. For -2, that's going to be the letter N. Similarly here, to confirm it, it's going to be the letter N. So that's a common question we might bring inside the exam as a multiple choice question, like what is the content or what is the output of this printing statement? Okay. So to print, this is an example to print all characters along with their index. So that's when you use the term subscript. Subscript is basically it's the index. Okay, when you want to do the positions as well as the string, so that's a count control loop. Why? Because I know the length of the string. The length. So for in, I will not put range. I will put the string itself. So for index or for in, okay, they did it with the range, but you can do it here with h, with high there, with the string itself. Then print the index and the content of that index, separated by a space. So you have the variable index will have values from 0 to, what is the length of data? It's 11 or 9, high there, 0, 1, the length 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the range of 9 will give you values from 0 to 8. Remember how range works. You will never reach the final value. So, and then print index, that's the first index 0, and the content of the string at that index. So data index, that's the letter H, and so on. Okay, so that's what we call traversing the contents of the string, that you can access all elements of the string individually. Okay, slicing is basically taking parts of the string or taking substrings from that string. So initially we did single characters. Each time I retrieve a character. But what if I want to retrieve more than just one character? And that's where slicing comes in. Okay. So I have my data, this content, that's data. And here I have initiated a loop for index and range length data. What's the length of data? 9. So range of 9 will give you values from 0 to 8, right? Range 9. So in this case, the values of index, if I want to do it this way, index will be 0. That's the first iteration. Second iteration is 1. Third iteration, 2, 3, 4, 5, 6, 7, and 8. That's all possible values for index in this loop. And they are incremented by 1 because I have the standard length range of 9. All right. So at each iteration, it will print index, these values, and data of index. Now, what is data? Is the string. Hide there. So the first iteration, data of 0, that's the first character. Data of 1, second character. Data of 2, and so on. So that's going to be data of index. So at this first thing, you have the letter H, you have the letter I, it's blank, that's the space. 3 is T, H, E, R, E, and with exclamation mark. So the printing statement will print index, and next to it, the character at that index. So each time the first iteration 0H, 1I, 2, and that's the space, nothing is there. 3T, and so on. So that's an example to display all characters along with their index. Clear? Okay, with slicing, that's the operator we use, colon. And the colon basically is an operator to give the range. So you might have a colon with a number and another number. Now, if you have nothing here, means that you start from the beginning. If you have nothing there, you do till the end. So for example, here, name of 0 till there is nothing, it means you are going till the end. So here, for example, A, and there's nothing from A to end. End mean was end of string. So for example, I started from 0 till the end of the string, and that's why it printed the whole thing. 0 to 1, it's going to be only one string. Pretty much like the range, you will not reach the last index. 0 to 2, the first two indices, 0 and 1, 2 will not be reached. So it's going to be my, and that's your file. That's your variable name, a variable value, my file.txt. Name 0. Okay, you start from nothing. So like here to A, start from 0 to A. A is the index, is the number. So start from 0 to A minus 1, sorry. You will not reach A. We'll give several examples complementary to this. Now, name minus 3 till the end. Now remember, minus 3 indices means what? The last 3 characters. So this one equivalent to what? Length of name minus 3 to avoid confusion. So what is the length of the string? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. Start from 7 minus 3 from 7. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is 7? TXT. So it return only TXT. It started from the 7th index till the end. Name 2 to 6. 2 is file, and we reach to 5. The letter F, 2, and the last character 5, E. So it's going to be the word file. You understand how slicing works? We'll go over it one more time. So assume that you have the string, my file. I will do them one by one. Okay. So name equal my file.txt. Okay, let me open the magnifier so it can be clear for all. Okay, something is wrong with my magnifier. Okay. Perfect. Okay, so we'll do slicing. We'll do name of, I start from nothing to 5. What it will return? From 0 to 4. So it's going to be 0, 1, 2, 3, 4. My file without the E. Well, let's do the counting. So that's 0, 1, 2, 3, 4. Again, I put 0 to 5, but 5 will not be included. So it's going to be 0 to 4. So again, that's a coincidence. That's just an example I gave. So in that case, it returned the word my file, but without the E. I started from the first point. This is equivalent from 0 to 5. Exactly the same. But putting the 0 is like meaningless. So if you keep it blank, you start from the beginning. Another example from 5 till the end, till the last index. Now, what is the first character at 5? E.txt. Very good. This is equivalent to 5 to length of name, and that's it. Because the length of name is the least, E.txt. But instead of writing length of name, just keep it empty. It will know by itself you are aiming for the end of the string. Let's do that example with a negative index, name of -3 till the end. Okay, it was txt, which is equivalent to start from where? Length of name -3. Instead of writing length of name, just put the negative index. It will do that. All right. Where this one might come, let's say, a little bit helpful. Usually extensions are 3 letters. Let's say .txt, mp3, mp4, those kind of extensions. Most of them are 3 letters. So you can run a code to probably count the data file types mp3 using this. Like you always examine the 3 characters of the file name. Accessing files, we'll do it next week, inshallah, when we deal with files. So we'll learn how to access files and their contents. So that's one way where this one is quite beneficial. Hey. And that's it about slicing. It's quite easy. You just know the tricks of not putting a value means you're either aiming for the point or the end. With the negative index is equivalent to the length of the variable or the length of the string minus that index. So those are the things that you need to be aware of. Okay. All right. Something here will not complicate it. It's quite easy. I don't want you to like understand every line of this code, but dealing with strings, sometimes when you want to send the content, usually a string over the internet, you want to, let's say, cipher that text or protect it, encrypt it. And there are a lot of softwares to do encryptions. There's the basic, very basic one to do encryption is something we call Caesar cipher. So that's it. Your string, you have it. You will do some encryption that when you read the string, it will be meaningless. Like it will be gibberish. No, not proper language. English, but scattered letters. And that's something we will learn right now when we do the encryption part and the decryption. So when you send that over the network, a lot of hackers can use sniffing softwares to access your data. So that's why it's important to do some data encryption, protect your data. So instead of sending the string as self, for example, hi there, it will be a different string. So there are two types of ciphering. We have the Caesar cipher and there is the block cipher. Caesar cipher is going to be our focus. Basically, I will not send the string itself. I will send the string shifted by one letter or two letters. So instead of sending the letter H, what's after H? I. So instead of H, I'll send I. Where's the letter I? I'll send the letter next to it, J, and so on. So when you translate this hi there into the new string, that new string will have no meaning. All right. So how to do that? You don't have to worry about the code provided. You just need to execute it. And the main issue when you execute the code, like here, when you copy it, there will be issues in these special characters and the quotations. Because today's lab will rely on this. And I'm telling you, most of your errors will be on the quotations and these special characters, plus, minus, and so on. All right, so what is Caesar cipher? Caesar cipher, basically, you replace each character in the text with a character at a given distance away. You know what do you mean by distance? Like the example I gave you. If I send the letter H and the distance is 1, means that the letter after H. The distance is 3, the 3 letters after H, and so on. The distance is 2, the second letter to H. So all my characters will be shifted by one distance. For example, the word invaders here. And if I have the string, the distance 3, it means that I'm going to shift each letter here with the 3 characters. So the letter I, J, K, L. So that's the letter L. That's lowercase l. An important thing. Do you remember the alphabet? A, B, C, D, E, F, G. I had students ask that during the exam. So memorize the A, B, C, D. Open YouTube, ABC song. I still sing it, by the way. When I go to the ABCs, I still sing it. So memorize the alphabet because you will need that in the exam. Okay. So the letter I translates to L when you have the distance 3, that I'm shifting by 3 letters. The letter N element O, P, Q. So it's going to be the letter Q. The letter V, W, X, U, V, W, X, Y. It's going to be Y. There we go. Letter Y. And so on. Now, the word I'm sending is invaders. But when the hackers retrieve it, he will see this text, which is meaningless. By the way, that's an easy way that this Caesar cipher is no longer used because the hacker can run a loop with all the possible distances and he can find the distance very easily. Okay, so to decrypt, we'll do the opposite. And that's the challenging part. Why? Because now you are moving 3 letters back. Well, it was easy with us when we did the ABC song, but when you go back with the letters, it's going to be hard. So for example, the letter V, exactly. It's better to write it. So when you have the letter V, what is the 3 characters before V? You repeat the ABC until you reach V, then you look back for the 3 characters. Or as your friend mentioned, if you have a question like that, it's better write it. STU, so is going to be the letter S for the letter V. For example, here, yeah, V, I shifted back to S. Translates back to S. No, SS, V, STU, V. All right. So to decrypt, apply the opposite. Instead of shifting forward with the letters, now you shift backwards with the letters. And here's an example. Okay, so you have A, B, C, D, E, and D, F, and so on. So you have the letters A, B, C, D, all the way to Z. Now, when you do a shifting, cipher text have shifting by 3. So D, E, F, G, and so on. Now, someone might ask, okay, so it's easy for us with the letters and translate by 3. Now, what are these numbers? 97, 98, 99, all the way to 122, and the same thing for the below. Basically, all characters that we have on the keyboard, they translate to numbers. And that's where the ASCII code fills in, the ASCII table. Now, remember, uppercase letters are different from lowercase letters. For us, it's easy to distinguish because just by looking. But how does the computer understand that? First of all, the computer understands that because all characters will translate to a number. For example, lowercase a here will translate to 61. Sorry, 97. Because there's the decimal part and there's the hexadecimal part. You did advanced math. You know that you did the numbering systems, binary, decimal, hexadecimal, octal. You've done that. Okay. All right. So how to translate from binary to decimal? Your multiplications. You have 1, 2, 4, 6. Sorry, 1, 2, 4, 8, 16, and so on. Then you add the numbers with that binary 1 in there. How to convert from decimal to binary? Division. A long division, and you always take what? The remainder. Okay. Okay, in this course, we are not worrying about that. How to convert from binary to hexadecimal? It's easy. You group 4 bits together. You group 4 bits together. From binary to hexadecimal, you group the bits. All 4 bits are one hexadecimal digit. And that's why for the hexadecimal, we have range from 0 to F, where F equivalent to 15. All right. As I mentioned, we don't have to worry about hexadecimals or binaries here. In this ASCII table, I will look only for the decimal value. So for the letter A, it translates to 97. That's lowercase a. For uppercase A, it translates to 65. So that's why the computer, when it reads uppercase A and lowercase a, they are totally different values. And that's why a computer distinguishes them. Now, why do I need this? It helps when you translate the character into decimal numbers because you need to do a shift by 1. How are you going to do the shift by 1? You cannot do letter C plus 1. It will not understand why letter C is a character, the number 1 is a number, there is a data mismatch, it will cause an error. So you will translate the character into its ASCII equivalent, add the number, go back to the character. And this is the code to do that. Again, you don't have to worry about the technical things in this code. I'm not going to ask you in the exam to write the code. In the lab, yeah, because you have the slides, you can use them to your benefit. And as I mentioned, you can copy the code, but your main challenge will be with these special characters like the single quotation plus minus something. Because the minus thing, for us, it looks like minus, but to the computer, you see it as dash, the hyphen. It's a bit different. So for example, this code here, please enter your plain text using whatever text you want. And then it will ask you for the distance, how many characters you want to shift. So you have 2 inputs, the string and the characters to do shift. The special command to change the character from character data type to its decimal equivalent from the ASCII code is ORD, ordinal value, ORD. So the ORD function returns the ordinal position in the ASCII sequence. Okay, so here you start with an empty string. Remember when we did the summations? We start with an empty ball, you keep adding to it. Here I'll start with an empty string, and each time I'll add to that string using concatenation. So at each iteration, I'll do concatenation. So first thing, I put my string, I put my distance, I will run a loop over the string contents. That's traversing. So go to the first character, second character, third, and so on and so on. So for example, I'll try with the word hello. So this is character 0, character 1, 2, 3, 4. By the way, I will not worry about those because I will not access them by index. I will access them by traversing. So for CH in plain text is hello. So the first iteration, it will go to the letter H. Second iteration, the letter E. Third iteration, the letter L. Fourth iteration, the letter O. And the last iteration, first, second, third, fourth. And the last iteration is the letter O. So this is my loop contents. That's the possible values for CH, the character. All right. So ordinal value, ORD value, I'm going to use the ordinal command, ORDCH. So here I'm going to put ORD for CH. So the letter H, uppercase. what is that translation for that in ASCII? We'll go back to the previous slide. The letter H, it's 72. So this command will return 72, which is the decimal value, regular number I can add to it. And that's it. So I did the translation to decimal. So cipher value is the ordinal value plus the distance. Let's assume the distance I put is the letter 3, as the number 3. That's my distance. All right. So then this 72 will translate to 75 because I added 3. So what is equivalent to 75 is the letter K. So H will translate to K. Okay, that's my result of translation. Then if cipher value larger than ordinal Z, now this is an optional character, optional line. Basically, I want my cipher text to be within just letters, A to Z. I don't want it to exceed that range. Because, for example, you put a character that, let's say, Y, and the distance is a 3. Let's go back here. I have the letter Y, my distance is 3, 124. It will return this is special character, but I want my cipher text to be within the characters only, A, B, C, all the way to Z. Uppercase, lowercase, doesn't matter. So if it exceeds that range, do a certain subtraction. So if it exceeds that range, you have this line ORD plus cipher value minus ORD and so on. Again, that's optional, but if you require that. If you do not require this restriction that I want only letters, you can remove this if statement. Remove it, it's optional. And that's it. After you do the ciphering, code plus equal. You remember this one? What does it mean? It means code equal code plus CHR of cipher value.
What is that?
Is this one that we contacted here? It's the 75 cipher value. So this line CHR of cipher value is 75 converted back to character. Go back here, 75. It will lead to the letter K. So in this one here is going to be the letter K. Code is empty string. Empty string plus the letter K concatenation. So it will return the letter K. So the new value of code now is no longer the empty string, it's become the letter K. So that's the first iteration. Now let's check the second iteration. Now the letter is E. Small e. Now what is the ordinal value for small e? 101. So here I will get 101.
So that's 3.
Now the cipher value plus 3, 104. Okay, if cipher value, again, let's not worry about this. Code plus equal. So here my code is the letter K plus the character of 104. So what is the character at 104? This one, the letter H. So I will have the letter H here. So it's K plus H. Now it's going to be KH. Doesn't matter what will be the output. It's KH. And so on until you are done with all the characters. So let me copy this code segment to Spider and try it with the hello and see if my output starts with KH at least. Okay, so I'll go. Now again, several errors. The first thing, the quotations. So use the proper quotations from Spider. Second one, third here. It will find it error by error. You don't expect to see all errors at once. Okay, similarly thing here. I'll start with the empty string. So here also the letter Z. And okay, see here, the letter A is fine, the letter Z is fine, but it's telling you that invalid character, the hyphen. So this hyphen here, it looks like a minus sign to us, but it's different. So I did it there, similar thing here. No longer an error. K or D value, there is a space. So let's remove that space. See, again, copying doesn't always lead to the right answer. Let's see now. Okay, so there are no errors. Let's run the code. Okay. Okay, enter a one word lowercase message. Okay, let's try with hello. Probably there will be an issue with the first letter. Distance is 3. And there you go. The output is KHOOR. So when let's say an entry-level hacker uses sniffing software and he intercepts the word hello, he will not read hello, he will read the word cool. Okay. So this is how the ciphering happens. That's when you have a regular text and you cipher it using Caesar cipher and you get what other text. In the exam, the question, I will not give you the code. I will give you a word with the distance. And you need to do that manually. You don't need the ASCII cable. You just need to memorize the alphabet. Okay. All righty. لا 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 لا. The if statement here, again, the purpose of this if statement is to ensure that the output is within the alphabet. You will not face special characters. So for example, if you put the letter Z, zebra, it will, distance is 3, it will translate to CHEUD. Now, why did it do C? Because Z go back to A, B, C.
It didn't go back to actual.
Yeah, did not reach this special characters. Now let's remove this if statement. I will comment it and run it, and we'll try again with zebra. And notice the difference at the first character. Distance is 3, and you have this curly brackets. So the purpose of this if statement is to bound my choices just to the alphabet. Do not reach special characters.
So what did the
I just remove this if statement. Because the purpose of this if statement is to limit the choices into the alphabet only. When you get rid of this, you can access all the other special characters in the ASCII table. Again, this code, you don't have to memorize it, just understand the purpose of each line. Because at the project, you might be, let's say, face a question like this, or in the lab today. So that's the purpose of this code. Okay, slideshow. That slide. Okay, so to decrypt, we do the opposite. What will be the difference? Previously, we added, now we subtract. So you have the encrypted text, the coded text, along with the distance. You start with a plain text, an empty string to add on it. And you start getting the ordinal value, go back to decimal, subtract the distance. There we added another line to ensure that you are within the alphabet, and concatenation is string to the other. And that's it. I will not go over this one. It's quite straightforward. So that's an example here. Enter one word, lowercase message, invaders, enter the distance, the value is 3. And the output will be the LQ whatever. The opposite, when you enter the same coded word and you enter the same distance, you will reach to the original text message. So basically, the sender and the receiver must know the key value, because you are sending the message to a certain destination,
So it's 3.
to a certain, let's say, to your friend. Let's say, for example, let's say sometimes people come up with their own, coded message between some friends, whatever. So the tashfir. So that's the way, like, they should know how to unlock this ciphering thing. So when you send a message, you tell your friend, okay, the distance will be 3. So when he received the coded message and apply that distance, and that's it, he will get the original message. But again, Caesar cipher, from the name Caesar, it's very old. Nobody is using it nowadays. So it's go back to the ancient times, very easier to break with modern computers. Block cipher, we are just to mention it, and you have the bolded text there. it uses an invertible matrix. The only question I might ask you in block cipher, what method is uses? What is the method? Invertible matrix. That's it. We may ask you about it in the project, because again, project is an open problem. You can use it, use a lot of resources. You can use ChatGPT, but if you understand that, if you understand the code ChatGPT brings to you. But yeah, that's how the block cipher works. So again, it's a plain text, but we don't use distance anymore. It's no longer a simple distance you shift the characters to. So each encrypted character is computed using 2 or more plain text characters, and the keyword here is an invertible matrix. Okay, some string methods. Again, string is a data structure. Data structure, now we can do methods on them. Methods, basically you have the string dot a method name. Remember, we did that previously in the math.py. So that's what we call methods. You have a module and dot something. Here we have the string, a data structure dot something, and that something will do a certain function to the original string. For example, we have the first command split. So in this one, list of words, sentence dot split, and you put a sentence here, it will basically split the sentence based on the spaces. So the output in this case will be a list. We did not talk about lists yet. It's going to be the focus next week. But list, basically, you start with a square bracket, another square bracket, and you have like elements separated by comments. So this is the first element, second element, third, fourth, five. And within the list, you are not limited of data types. You can have here a string. You can have a float. You can have an integer. You can have whatever. So with strings, with lists, you have flexibility of combining several data types in one certain variable. All right. So this example here, enter a message, and the user put this statement. This sentence has no long words. And we did sentence.split. Why sentence? This is your variable name, sentence, and the content is this sentence has no long words. Now, when you did this split, it will create a list of each component here separated by spaces. So when you look here, this space, so it's going to be, this is your first element. This, comma, sentence, comma, has no long words. So basically, to create a list of length 6. Why 6? Because I have 6 words in this case. All right, so print, there are length of list of words. Again, list of words, it's a list that's a different data type. We'll deal more about it next week. And that's it. To know the length of the words in this sentence, you run it over a loop, and each time you add the length of each word. And to find the average word, again, that's an example. You don't have to understand these technicalities about this example. Basically, the example is write a sentence and find the average words per average characters per word. This is a scenario example. And this is how to do it. The average characters per word. So first you need to split the sentence into words. Then you run a loop over each word. Each time you add the length of each word to a counter to summation. And then to find the average, initially I found the number of words and I know the number of characters overall. To find the average, you divide the number of characters over the number of words. All right, so here print the average word length is summation, which is this summation of all letters or all characters in the word, except for the spaces. Here spaces will not be counted. Divided by the length of list of words, which is this list that has 6 elements. So let's do an example here and to show you how the output list of words look like. Okay, I'm gonna copy everything and do the cleanup there. Okay, first of all, we don't have these arrows. So I'm gonna remove the arrows at the beginning. Okay, so these actually are answer of this code. This one is also an answer of this word. Okay, there's nothing here. So have the for loop. Okay, and this one is running the output. A common thing, you change the string operator, the double quotation. Okay, similar thing here. There are is the average. List of words. Okay, let's assume everything works fine. One thing, I'll change the variable name the sum because the sum is a keyword in Python. I'll use the sum. Let's clear all the data content there and let's run the code. All right, enter a sentence. Still what? Yeah, it will return an error. It's interesting. It did not return a statement or a warning that this sum is not there. Because it's a keyword, it assumed that the word is fine. Okay, let's double run the code, enter a sentence. So let's follow the same example. There are no long words. 1, 2, 3, 4, 5. So what was the example? This sentence has long words. I'm gonna copy the whole thing. Okay, this sentence has no long words. And there you go. So I put this string, and there are 6 words in the string. The average word length is 45. Now let's check. Let's check our variables. First of all, list of words. That's the data type list, which will be the focus next week. And see the contents here. Like we started with a square bracket, which is an indicator that I'm starting a list. That's a list. And each element is one word from that list. Basically, the split command, if it's empty here, then the splitting criteria will be the spaces. It will be the space. So in this case, I have the string. This sentence has no long words. This space, so that's one word. Sentence space, that's the second word. Has space, no space, long space, words. So basically, it divided this sentence based on the spaces. And each element will be stored in the list. So that's the first element of the list. That's the first word, second word, and so on. So that's my input. Now the summation, basically I'm gonna count all the characters in the string. So if I want to know the length of each character, I will do, each word, let's say, I'm gonna write a simple loop for I in range, or for I in list of words. Okay, I'm gonna print the word and the length. So the word is list of words I, so access each word. I'm gonna do a concatenation, and its length is, I'm gonna put colons, length of list of words I. So let's run it and see. Hopefully there are no errors. And this must be integers or slices, not a string. Okay. So print list of words, print I. Okay. So, and length of I. Okay, let's run one more time. There you go. So this and its length is 4. Sentence and its length is 8. Has and its length is 3. No and its length is 2. Long and its length is 4 words. And so I displayed each word and its length, basically the number of characters. How did I do that? So I did this for loop that I'm traversing over the contents of each word in the list. So here, list of words. So what will be the possible values for I? It's going to be this sentence has no long words. So 6 possibilities for I. So I'm going to run a loop over these 3 words. And at each iteration, print the word I concatenated with and its length is the length of I, which is the length of that word. And that's why it displayed each word and its length. All right, so to confirm, 4 plus 8, 12, plus 3, 15, plus 2, 17, plus 4, 21, plus 6, 28. So the total, let's say, characters here is 27. And you can confirm here the sum, which is the sum of characters, it is 27. To find the average, it's going to be 27 over the length of this list, which is this command. The average length here is the sum divided over the length of list of words. Again, that's an example to illustrate of the use of this splitting technique, split. Now, can I change the criteria splitting? Yes. So again, when you have split empty parentheses, it means that the splitting criteria is the space. What are other alternatives? The best way is when you want to find the extension of a file. How are you going to do that? What will be the splitting criteria? Extension of a file, my file.txt. So dot. So the splitting criteria will be dot. Okay, we'll go back to the slides. Slideshow from this current slide. So let's understand the logic of this one. Okay, we did not put it here. Yeah, for example, extraction of file name extension. Now remember, each dot split will give you a list. Now, if I have the file name, it's only one string, and the splitting criteria is the dot. So what will be the length of the output? It will be the file name and the extension, 2. If you are looking for the extension, you will need only the access to the second element, not the first. So pretty much like here, my file.txt dot split with the dot, it will return a list of my file txt. By the way, the dot will be gone because that's the splitting criteria. It's no longer part of this. Well, the string will be there. You do not change it, but you splitted that output. Here, my file.py, the same thing here. Now, where this one comes in hand, when you want, let's say you have a folder with a lot of files in there and you want to count your file types. So you run it over a loop like this. You do the splitting criteria and you have a counter. And let's say your Python files, you do it there and so on and so on. So this is an example to access the last element, file name.split. So basically it will create a list like this. -1 means what? Remember, what does -1 do? Accessing the last element, which is basically the extension. So this is the easy way to find the extension of a certain file. So here methods are like functions, but has slightly different syntax. We'll talk about functions at the last lecture, inshallah. Methods can expect arguments and return values. A method knows about basically return values. That means that you can assign them to a variable. A method knows about the internal state of the object, which is called. All Python, all data values are objects. Again, let's not worry about these methodologies. If you want to know more, there is always this help command, help str.split, for example. If you want to know more about the split, you go to Python, type help, and let's see, str.split. Let me see if it will return any answer. Okay, so probably not a split. Let's see. I think I should put the string name itself. So where's my string sentence? Split. There you go. So this one will open the help file associated with this one. Might be complicated because we did not discuss what we mean by mutable and immutable, right? That will be part of the lists because there's another data type called forget that data type. You know what is the name? Something to the like the list. Tuples. Tuple. That's another data type, pretty much like the list, but you cannot modify it. You cannot add to it. You cannot change it. That's what we call immutable. Okay, so if we go back to the slides. Okay, so those are examples to do the splitting based on the dot. And in summary, a string is a sequence of 0 or more characters. 0 is a special case where you have the empty string. The length function returns the length of or the number of characters in a string. String is a mutable data structure. Mutable, though we did not talk about it, mutable means that you can do changes to it. You can add to it, you can extract, you can split it, you can change it to uppercase, to lowercase. We'll see an example now about uppercase, lowercase. The subscript operator, the square brackets along with the colon to do slicing. This command in operator to detect the presence of an absence of a substring in a string. We did not talk about it, but we see that like when you have a range in and so on. I think we'll talk about it also in lists. A method is operation that is used with an object. The string type includes many useful methods with string objects. Okay, let's see. Yeah, I think we covered everything here. Let's do an example of the n and the uppercase, lowercase. So let's check the string. I have the string sentence. This sentence has no long words. I want to check if is the word no there or not. CLS. So basically, no in sentence. So I'm kind of asking, is the word no inside this sentence? No, check the sentence. This sentence has no long words. So this will return a binary value, either true or false. Okay. To confirm, just try, say yes. Does it exist in the sentence? No. So it will return false. So this N operator, just check if there is a word within that sentence. And it will return either true or false. And you can assign it to a value. Confirm, for example, equal, and you have a confirm, which is a Boolean data type. And we know what Boolean data types, either true or false. In this first case, it is false. We'll try with this one. No, it is true. Okay. Confirm, because I need to change the variable name. It is true. So that's how to confirm. Where does that one, let's say that become beneficially? Assume that you have a long text and you're looking for a certain keyword in there. And you just simply do this, confirm equal, and you put this N operator there to check if this string or substring exists in that string. Now changing to uppercase, lowercase. So I have my sentence. And if I recall well, upper. That's it. So there you go. This sentence has no long words. So that's the output. See my sentence. This sentence has no long words. And the output is this sentence has no long words, but all the characters are what? Uppercase. So that's one of the methods. Where does this one come in handy? Sometimes also when we want to do it with lower. So new sentence equal. Okay, so I have the new sentence. This sentence has no long words. assume that you are looking for a certain word in a certain string. And we know the cases with uppercase, lowercase. So the first thing you do, usually you convert the string into lowercase letters or uppercase letters and check for that special word or special string. For example, you remember last week when we did counting characters, the vowels, E, O, U, I, and A, I believe. Those are the vowels in English. Now assume that someone put the string and part of these characters are uppercase. So to confirm that you count all characters, whether they are uppercase or lowercase, you convert the initial string into lowercase letters and do your conditional statement there. In that case, you don't have to look for 10 cases of uppercase A, lowercase a, uppercase U, lowercase u, and so on. You're looking only for the first 5 with all lowercase, but make sure your sentence is converted to lowercase letters first. And that's it for this lecture. Very easy lecture, and I believe the lab is also very short and very easy. Right now, I'll go and bring your exam papers. I just need to take scan copies of them. Once I do the scannings, I'll bring it to the class. Okay. All right. So we'll stop the recording here. Stop. All right, Saeed.